Hello everyone, it's February 12th. Just finished the contest. Was not the best and also not the worst. I mean, I did okay. Just normal performance. 3 out of 4. That's how it always um, how it always is for me. 3 out of 4. Nothing too good, nothing too bad. I'm gonna take a look. I got 3, and then can figure out the last one. This is actually the last one, maximum and sums. I throw together some pretty spaghetti code, and I was hoping that this can pass, but it got timed out. So same as yesterday, I got timed out a lot yesterday, and then yeah, I can see the ranking. That's the ranking. I mean, I had a little bit issue here, which I believe these people have the same. We just forgot to test the empty, one of the edge case. Right? I didn't test the edge case. This took a little bit longer than I wanted. Right? This one took a little bit longer, but it's fine. It's not too big an issue. But the last one, just I can't do it. Can't do it. Anyway, we all have to go back. Maybe tomorrow I can give them a little. I don't think any more thinking will. Maybe hint. I can try some hint. And also, we haven't finished this one, so now we have 2 questions that we haven't finished, and they all timed out. Now this one I need to mark as timeout, and don't forget we have this one is also yesterday is also timeout, so I have to figure this one out as well. But anyway, let's just go to the one for today, which is I think I pressed the wrong button. Okay, so let's just do this. All right, we do this one, and after we do this one, we go back to yesterday's and see if we can solve it. All right. Oh, this is solved a long time ago. Twice. This is the third time. This was just on my own, and this is one of the contests, not contests, or the challenge in the past. But what we want? Give an integer array of unique, all possible subsets, all the power sets. There is a way to do it. We have this and everything, and get everything out, right? Get everything out, and we just append to it, right? So we get this out, we append 1, and add to the end. Really? I got 1, 2, 3, and then I need to write this out. I remember doing this. All numbers are unique. All possible subsets. Okay, so I can get 1, and I cannot get 1, 1. I have to get a 1, 2, and a 1, 2, 3, and 2, 2, 3. What was the method used in the past to get power set? Actually, you know what? I think it's recursion. I have 1, right? So I find all the power sets that can be formed in 1, 2, 3, and we just in any order. I mean, I can just say find everything in 1, 2, and then we just append 3 to it. Everything in 1, 2 shall be empty 1, 2, and a 1, 2, right? That's everything in 1, 2, and I'll append 3 to it, which will give me 3, 1, 3, 2, 3, 1, 2, 3, and the empty set, all right? So what we want is, and then I have to build 1, 2, right? So build 1, 2, I just need to build 1. 1 is just empty and 1, right? And then we put 2 into it, which will get this 1, 2, and a 1, 2. And the whole thing put 3 into it. Yeah, I think I just start with the empty and the first one, and then we go to the second one. Yeah, I think I figured it out. Yeah, they usually throw a softball after the contest, kind of just chill, right? Give us some chill. Otherwise, the brain is gonna explode. Okay, so this, I have never had like 2 problems unsolved. Okay, so rest is gonna be this, and then for any nums, we just say for rest, for p in rest. That's probably not a good idea because I need to append to rest. So I should say for I in range len rest, okay, and then we say rest dot append rest I, right, plus n, and then return rest. I think this shall suffice. So I have a 1, 2, 3. Result shall be this. Nice and easy. Next one is 0. Result shall be and 0. Okay, so this is nums. This is subsets. Nums. Probably just sorted, just in case. Just in case we need to. Yeah. I think that is how it's done. We can go. I have confidence in this one. Yeah. Is that 70? 78. Oh, I don't want to see the discussion. This is the whole problem. 78. I've done this one 2 times in the past, and I have a memory of how a power set is constructed. So I was able to solve this problem fairly fast. I don't know, that's what, that 2 to the n, right? I think it's 2 to the n. Because the total, yeah, 3, we have that's 2 to the n, and it's a 37 milliseconds, 64% ranking. All I want to do is just check this one, and that's it. Nothing else. Maybe I should like this one. I also have solutions, so not sure if that's a solution. Subsets. Cascading. That's the way. That's the method I use, right? N times 2 to the n. Binary sorted subsets. Oh. N times. Why is n times? Copy. As this part. These two is 2 to the n, and this is on. Okay, I agree. Backtracking. Now I want to see this one. Oh, origin from this dude. This dude is really good. Bit mask. Ah, yes. Ah. Yeah, we can try this one. Oh. So I can generate all the I can generate everything from 1 to 1 left shift. 1 left shift. What's the requirement? Number of length, right? So 1 left shift this minus 1. Yeah. I generate all the number for each one. I just go through. If it's a 0, then I don't put this one. If it's a 1, I push this one in. And if it's a 0, I just move. Yeah. That's a fun one. Git mask method from the official solution. If I have nums, I will just say for I in range len nums. Actually, no. It's gonna be because it's gonna be 0 to the end, right? So 1 left shift len nums. Oh yeah, I just 1 left shift len nums. And then rest shall equal to this. And I have an I, right? And we need to get a binary I. And we need the left pet 0, right? How do we do that? Which I forgot. I'm going to PT Python again. I just have string, right? Say 5. 5. I think it's a 0, 2. Oh, it has to be binary value. 0 to b. 0, 5b. Yeah, so it's going to be binary str is going to be f string I this 0 pet 0, how long? Len nums, that's putting an n equals to len nums, right? And then there's left shift n, and then this should be I forgot. Let's say a equals 5. Can we do a here? Yes, we can. Like that, right? And then, rest.append a this, and then for can say for d in this, right? id jd in enumerate. Oh my god, enumerate this thing, right? And enumerate this. If d is equal to 1, then rest dot append nums j, right? And return rest. This is a fun method. I think it should be good. Oopsie doozy. Huh? Oh, my bad. -1. Oopsie doozy. What is this? I don't understand. Hold on. Hold on. Make sure every step's correct. Huh? Oh, B. My dear God. I forgot the B. Yep. I forgot a B. Ah. Always test. This is not necessary to have this. Yeah. Alright, so that's that. Solve this. Cool. The art of computer program. Yeah. I don't even think I'll be able to. Backtracking. Alright, let's go back to this one. So I think our idea is okay, but it's not working. So what I think is to, instead of going from 0 to this, right? I already have this. What I can do, because it's going to be a palindrome, so I can just find the largest gap, right? I find the palindrome within this largest gap, right? And then within this largest gap, what I can say is I in range low to this. The largest gap. I want to find a maximum within this, right? Which is find a maximum within this, right? And to find a maximum within this, I use this method. We have a low and a high, and then I think I was fixing a high, but going from low, right? We say maximum within this is just maximum within this, everything, right? So I'm going to go here, try to find the maximum, low to high. And I even use bisect to facilitate, right? It's bisect to facilitate, we get J, we do ba ba ba, and then we do this, and then return this, right? So this is all fine. So I think my way is just going to say position, right? When I say rest equals 0, because we want to find maximum, and we say for position letter. So for position list, right? Position list. For position list in position.values, say if position list if len this is equal to actually I can do one more. If this is equal to 1, if low plus 1 equal to high, turn 2, right? And here's the same. If this is equal to 1, then rest equals max rest on 1, right? Else, if it's larger than 1, then we can rest equals max rest helper low. So low is going to be this plus 1. High is going to be this minus 1. So right? So low is going to be here, high is going to be here. That's not low plus 1. So what I think is that's just Aleph. Len position is equal to 2, right? And because I don't want to pass, I cannot pass low and high in this case. And position list 0 plus 1 equal to position list 1, right? Same as this. If in this case, rest equals to max, rest and 2. Else, now I know they're, even if it's 2, they're different by more than this. So I can say position list 0 plus 1, position list 1, no, minus 1, minus 1, right? So it will be helper this plus 2. And we return rest. I'm seeing this one's faster. Who knows? It tells me TLE. That's the case. Oh, I think that's the case. Nah, well, I think it's still timeout. I know it's DP. Huh. Longest common subsequence. It has something to do with longest common subsequence. Okay. Longest. I know longest common subsequence. I'm gonna find the longest palindromic subsequence. If you think about it, it is like the longest common subsequence. There's like two subsequences need to be the same. One from start to end, the other from end to start. What are you saying? If they're the same. I have 2 pointers, one at the front, the other at the end. If they're the same, then we move inwards. Because no matter what, if we have front and end the same, they must be included in the longest. Okay, I think we're on to something. Alright, so if they're the same, then move inwards. If they're not the same, we either right moving inward, 1, and then we compare this, or left move inward, 1. Right? Because we say if they're the same, then we're gonna do the maximum of this. And to find the maximum of this, right, to find the maximum of this, we compare. If they're the same, the maximum of this. If they're not the same, then either with the maximum of this, the maximum of this. How do you feel about deleting everything? Fine. Doesn't matter. So we have a low and a high. Right, this one shall return an int. Okay. Then we say if s low is equal to s high, when the return 2 plus s helper low plus 1, high minus 1. And of course, we'll have to say low plus 1, high minus 1. So if low is equal to high, return 1. Right? And here, low plus 1, high minus 1, which is fine. So over 2, low plus 1, high minus 1. So if we do low plus 1 and a high minus 1, right, then we just return 0. And say if low is larger than high, then we just return 0. So if equal, we return this. If they're not equal, then we return. If these two are not equal, so they cannot be either this or this, right? So I'm going to return maximum helper low plus 1, high, or helper low and high minus 1. Either one of them. And we're going to cache this. So we're going to do return helper 0 and the line is minus 1. Think we might get it. Dun 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 dun. Dun 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 dun. Yep. And this is it. I need to say this is a hint. The hint is LCS. Well, I wasn't able to solve this yesterday. Got tons of TLE, and I knew, all right, and I knew that the solution yesterday was bad because the logic was very convoluted, very convoluted. Today, I still couldn't crack it, so I took a look at the hint. Well, not really the hint. I took a look at similar problems, right? Similar problems. They're called problems. Similar questions, and noticed that LCS was there. Thus, I started to think in terms of LCS. I mean, palindrome is similar to LCS in the sense that we are trying to find the common subsequence from the back, right? From the front, and from the back. Thus, I had the idea of putting the two pointers, one at the beginning and one at the back, and then move them in towards each other, inwards, right? We'll move them inwards. The logic is the same as LCS. If the end, right? If I just say if S low is equal to S high, then these two letters must be involved in the longest palindrome. Then we move both pointers. If S low is not equal to, right? If it's not equal to S high, right? If they're not equal to, then we do the crisscross, the cross application. I don't know how to cross. We'll do the cross calling, right? We'll do the cross calling of low plus 1 high, right? And low high minus 1. That's it. O squared. Yeah, I think this is those questions that if you know how to solve it, it's not hard. But if you don't, you get stuck. Top down, bottom up, pick one. I like the recursion. Yeah, I like the recursion. But we can do it this way too. Yeah, we just going from the. Wait, how do you build the bottom up for this one? All of this was 1. I is for j is I plus 1. Because we want to find, yeah, so we're gonna I, and we're gonna find everything. I, because we have found in between already. So I is here, we want to find I to j, right? I to j, underneath everything in between is already found, because we have found this one already. Okay, I to j, we found this. Yeah, that will work. But too lazy to do the bottom up. Top down is good enough for me. Evolve from brute force. Yeah, I like the recursion because it's just easier to write. Yeah, I always like top down. Top down is easier in terms of logic. Okay, so yeah, surprisingly we got this done. Maybe we can do the same thing tomorrow, and I'm not gonna try to solve that. I'm not gonna try to solve this one tomorrow. Right now, I'm gonna wait until tomorrow. I remember I have this. I did pretty good on this one. I did pretty bad on this one. This one looks like spaghetti code, but it's fine. Yeah, we're gonna handle this tomorrow because tomorrow's gonna be easy. So I'm going to handle this one tomorrow. Look at this. We're heading towards 714. Should be 15 right now, right? Because I just solved one problem. Oh, maybe it just counts as attempted. Yeah, 15. 715. So we have 715 now. 285 problems to go. Yeah, we'll get there. We'll get to 1,000. Alright, that'll be it today. I'll see you guys tomorrow. Adios.